think I've got all the technical difficulties worked out again. Welcome back, everybody. Today we are going to be continuing the big project that we started a few weeks ago. I think this is on to part 5 now, and we are working on upgrading elm-html-test for Elm 0.19. I think we're about a third of the way through it. We had a couple questions of how some of the internal code worked last time, which I got some confirmation about. So I think we're ready to move forward today. So, oh, hey Martin, good to see you in the chat. And I guess let's jump right in. If anyone new is in the chat, feel free to say hi, and good to see the rest of you. And let's go ahead and figure out where we left off last time. Let's see, so elm-html-test in Elm 18, if you recall, if you watched the previous sections, consisted of 3 separate Elm packages. We're basically taking all 3 of those and combining them into Elm Explorations Test, which is the new testing package in Elm 19. So let's see. I guess let's grab, let's get this git log up here. Okay, so I guess we have a lot of stuff in progress that we haven't committed yet. Okay, looks like a whole bunch of stuff. elm-html-test. Oh, actually this is in the wrong repo. This is the repo that we want. Ah, great, and here we are. We were looking at test failures, and we're down to 104 test failures. And we do have a to-do list. Okay, so I think I opened the wrong folder. Yep, okay, I opened the wrong window here in VS Code. Let's open the correct one. And then we can, oh, okay, it just reused the window. Great. And we set this up to hopefully run everything with npm test. All right. So we did get test failures. Yep, okay, 104 test failures. So that looks like the same place we left off last time. And let's check our to-do list. So get test to compile, we've done that. We're working on getting the test to pass. Okay, and then we have some other notes from last time. Let's check real quick about the last changes that we committed. All right, we were debugging some of the kernel code, and we were debugging this stuff about the attributes within the virtual DOM code. So the way elm-html-test, if you remember, works is it grabs the virtual DOM objects that are created by the elm-html package and is able to inspect them for testing purposes. So a lot of that internal representation changed in Elm 19. And okay, so here's some code that we're hoping to uncomment if it's covered by future tests. This is the code we worked through last time of basically updating this decoder that can decode the HTML attributes. Okay, we added that, and we added some notes for the future. Okay, cool. So I think our next step is going to be going to the tests file, and we'll just grab the next file's worth of tests. There were a bunch of files in here that we pulled over from the elm-html package. And unlike a normal Elm package. The tests in here are kind of unusual, so we have to explicitly list them all. So I think attributes is the one we fixed. I'm going to comment out the rest of these and run this. I think all the 104 failing tests are within these. So let's just verify that. Yeah, great. Okay. So these all passed, so let's go on to the next one, descendant.all. I'm not sure from the name what those tests will actually involve. I guess nested DOM elements. Okay, so we've got one failure in here. So let's go check it out. Descendant. Okay, and this test contains assertion, returns false if it does not contain the node. All right, so that's this test. So I guess we got to figure out why this is failing. So we're building wrapper. What is wrapper? Wrapper's here. It's a function that takes some HTML and a potential descendant and returns a bool. Okay, so I guess, oh, I see. Okay, so isDescendant looks like the function that this file is actually trying to test, which is from test HTML descendant module. So that makes sense with the name of this. Should probably rename this, but I'm going to worry about that once we get everything compiling. I guess I'll make a note, rename to test.html.descendant-test. Great. Well, let's check and see if there's any docs on this real quick. isDescendant. Oh, to do don't expose this module. Okay, we added that last time, or a couple times ago. This takes a list of elm-htmls. This is our representation of virtual DOM stuff. And then a potential descendant, and returns whether we find it or not. Okay. And this just recurses. So if the list is empty, it returns false. If there's at least one item in the list, we take that. If it's equal to the descendant, it's true. Otherwise, we recurse passing prepend children. What does prepend children do? This is interesting. Current and rest. So it calls us prepend children, takes an item. Why do we need prepend children instead of just reassembling the list? Prepend children takes a parent node and a node list. If it's a node entry, we concat them, otherwise we return the node list. I'm not sure what this is for. All right, well, I'm not sure if the test failure is because of something in there. What is the actual failure? So isDescendant should return false if it doesn't contain the node. Oh, and this is just empty string. Why don't we change this to expect dot equal false. Let's change these also. These empty messages I don't think are that useful. So anywhere we have expect true empty string, we'll change that to expect equal the value true. Okay, well, that's what the problem is. So my question is, why is this happening? Let's go ahead and add only and focus on just this one test, and then let's add some debugging in the function itself, see if we can figure out what's going on. All right, so we get HTML. I guess let's debug here. And let's see what those values are. Okay, we only call this once. Ah, interesting. Okay. So the HTML actually is this fake HTML that we stuck in the case that we can't decode things, because there was a debug.crash that was in the code, which is not allowed to be in published packages in Elm-19 anymore. So as a shortcut for now, and we were going to revisit this later, we just create a fake HTML document that has the error message in it. So that's what we're getting. So I guess we should investigate the reason why that's happening. Please report the error. Okay, expecting object with a field named type. So this presumably is coming from a decoder somewhere. Let's take a step back for a second, and I'm wondering if one of these other tests is going to be more directly related to this decoder. I'm wondering if queries is maybe the next one we should look at. I think let's put descendant on pause for a moment and take a look at what's in queries. So I think this might have some more basic tests. Here we go. Sees it's in a section. I guess what I'm looking for is a test that's about decoding the HTML nodes themselves from virtual DOM. Maybe selectors is more basic than queries. Let's see. Oh, this doesn't have very many tests in it at all. Okay. And then test example.all. I'm assuming that's more of like an integration test. Yeah, this uses queries and stuff like that. Okay. I'm not sure which will be the easiest. Let's try running the queries test real quick and see if that gives some errors that look simpler than the descendant one. I might want to jump back to the descendant one now that I've looked at this. Okay, there's 64 tests in queries. And this, we saw this briefly last time. This basically has an entire test suite that it runs twice. Once on normal HTML nodes and once on lazy HTML nodes. Let's comment out the lazy ones temporarily. And let's try just this first test. Okay, HTML test queries finds itself, sees it's a section root class. Okay, query from HTML, error. This is the This is the fake error that we're producing, and it doesn't have this matching thing. Okay, I think the errors produced here are a bit more verbose, and we're also testing a more public module in here. So I think let's stick with queries for now. We'll come back to descendant later. I'm guessing it'll probably just be fixed by the time we fix the stuff in queries. Okay, so I guess our next step is we need to figure out where this error is coming from. This looks like it's going to be a decoder, a problem with a decoder. Last week we fixed the attributes decoder, and I think we noticed that there was also a DOM node decoder. So I'm suspecting that's the one that's the problem here. But this message is kind of vague. It doesn't directly point to things. Let's see, so internal type. So here's a decoder that's looking for a field named type. So presumably this is the decoder. I'm curious how we can actually print out the value, or the JSON value that we're trying to use the decoder on. Let's see, so here, decode, this takes an HTML context, decode elm-html. Okay, decode a JSON object into elm-html. You have to pass a function that decodes events from HTML nodes. I see. If you don't want to decode messages, you can just pass a function that always returns unit. Okay, this function takes a list of taggers, an event handler, and gives a decoder of message. Okay, that's for event handling stuff, which we will get to probably right after we finish fixing the query stuff. If you do want to decode them, blah, 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 okay. All right, I'm gonna look for where this decoder itself is called and see if we have access to the JSON value at that point so that we can print it out in the console when we're running these tests and hopefully see what it actually looks like. Let's see, decode, that's exposed. Here we go, this looks like it. We're decoding the value. This is calling toJSON. And that's from here. This takes an HTML value. Okay. And this, I think, is the native code function we were looking at last time. So this value that we return from the toJSON is what we want to log. And I hope JSON values print out with the Elm debugger. If not, we can jump to the kernel code and log it out there. This is the toJSON HTML. All right, let's see if that prints anything, or prints anything useful. No, no, it does not. Okay. In that case, let's try logging it from the JavaScript kernel code. So let's jump to this function. That's going to be in HTML as JSON. toJSON. Okay, here. So this is what it's going to return. Let's just introduce a variable for the moment. Console.log that and return it. Okay, this should at least show us what the data looks like. All right, great. Okay, so I think this is going to basically be the same kind of thing that we went through in fixing the attributes decoder, except now we're just decoding DOM nodes instead. So this is going to involve figuring out basically what the new field names are for all of these things. Let's see, so internal types, this is the file we're going to mainly be working on. And where was that decoder? Here we go. Okay. So type had, in elm-18, there was a field called type in these nodes. It had one of these values, text, key node, node, custom tagger, thunk, or other unknown. Okay. So probably all of these things we're going to have to find the corresponding new value for. In this case, oh, interesting. It looks like a lot of these also got turned into numbers instead of strings. So I'm pretty sure this dollar field is going to be the new version of the new name for the type field. I guess it'll probably be easiest if we look up the source code for virtual DOM and see if we can see some names in the source code that correspond to some of this stuff. And I guess we're going to have to start extracting some constants and things like that. All right, so let's go do that. So we are looking for Elm virtual DOM, and specifically the source code for it. This should be here. Okay, so this I'm pretty sure is the right repository. These constants are going to be in the kernel code. Okay, and let's look for things like these. Maybe keyed node. Let's search for keyed. There we go, keyed node. And this in the source code is the constant. Okay, great. So I guess we're just going to have to find out what these values have turned into. Hopefully there's tests for all this. I'm going to start just defining a record right here where we can keep track of all these new constants. Let's call this virtual DOM kernel constants, and we'll just make a record. Let's call this node type is going to be $, I'm pretty sure. Or actually, we can kind of confirm that here. So instead of this, we're now going to be using virtual DOM kernel constants dot node type instead of string type. Let's see. And then I guess all of these we're going to need to find also. So I think I'm just going to fill these in for the moment. Node type text. Node type keyed node. Node type node. Okay. Node type custom. Node type tagger and thunk. Okay, so these are all the ones we're going to need to fill in here. Let's see, I think we can just replace all this. Oh, I guess we can't refer to variables in case statements like this. Okay, so we're gonna have to convert this to if statements. To do this, if type string equals, so let's see, what's the best way to do this? I think we can do it this way. We will say else if type string equals virtual DOM kernel constants dot node type whatever, then okay, and this is node type text, node type keyed node, node type node, node type custom, node type tagger, node type thunk. This is the else case, and the first one is this one. Okay, there we go. And I guess we'll also need to figure out what this field is also. To do, what is the new name of this field? Okay, so I think this one's correct, and if we run this, I'm not sure which, this looks like a normal node, so I'm expecting to get an error something about, actually it should hit this case. It should say no such type as, and give us some type. So let's see if we understand what's going on. Expecting an object with a field named $. Okay, that is not what I was expecting. So all this stuff that we're printing looks like it has a field named $. One thing I'm remembering from when we fixed this for the attribute decoder is that we actually had to add this wrapping to turn a JSON, or to turn a JavaScript object into an Elm JSON value. So I'm gonna guess that we actually need to add this around the JavaScript object so that Elm will actually interpret it as a JSON value. If we do that, let's see if it gives us a different error message. Yeah, okay, it does. And it says problem with the value at JSON sub $. It was expecting a string. And actually that is case we saw in the source code here in the elm-19 virtual DOM, that these type fields are actually now integers, and we can also see that in the stuff we printed out here. Okay, so these all actually will be integers. Stick -1 in, I guess. And that means this needs to be int. And type string is no longer a string. This is node type, I guess. And we will need to string.fromInt down here when we print a failure message. All right, that should get us on. Hey, great. Okay, no such type as 1. And there's the whole JSON. Okay, so I'm pretty sure 1 corresponds to node. If we look at this, I'm assuming this top thing, so this is the HTML that we're presumably representing. It's a section node. It has some attributes. Yeah, this is the stuff that we fixed in the attributes decoder last time. Okay, let's stick in node type node as 1 for now. I did get some confirmation, by the way, that the way these constants are turned into literal values in the compiled code is deterministic and only depends on the content of this file itself, or whichever file is defining these constants. So I talked with Evan briefly that potentially all of these constants we could expose to this module from the virtual DOM library, but it should be safe enough to just fill these in and get everything working at the moment. And the virtual DOM library itself should be pretty stable as well. All right, so expecting an object with field named tag. That is a new message, so great. Problem with the given value. Okay, so where is it looking for tag? I guess that's going to be in the decode node. Okay, so that's probably going to be in here. And I'm assuming it means the DOM node tag, or the name of the DOM node, which is supposed to be section, and the constant for that field is going to be C. So let's see, node type node tag. Not sure the best way to name these. I guess we should maybe name, yeah, okay. Yeah, these fields are just constants. Okay, let's just call this tag. And this is going to be the string C, I'm pretty sure. Now we just need to find where that's used, which this is the branch we're going into, node type node. Decode node is down here. Okay, we've got a bunch of fields that we're going to need. So tag, children, facts, and descendants count. Tag, facts, kids, it's called now. Okay. Okay, so we can fill these all in, I think. So this field is going to be virtual DOM constants.tag, virtual DOM constants.kids, virtual DOM constants.facts, and virtual DOM constants.descendant count. All right, then we got to add all of these, kids, facts, and descendants count. Kids, facts equals, and descendants count equals. And what do we have here? I think D is going to be facts, because this has things like the class name, the attributes. E, this looks like it contains other virtual DOM nodes. It's like here's a div, here's a header. So I think E must be kids. And descendants count is probably whatever's left. B, it's a number. Sounds good. All right, let's try that out. All right, definitely a different error message. So json.e sub 0.e sub 0. So that's E was kids in both of those cases. No such type as 0. So we're on to another type. This is home. Let's look at the HTML that we're actually using in this test and see what this is supposed to be. So here's the test we're running right now. Output is the HTML that's getting passed. Actually, it's a single, which means it's already been turned from virtual DOM into an elm-html result. So this is sample HTML. Where does that come from? Right here. Okay, so what is home in here? Oh, I see. This is just a text node. So 0 must be text. Did we have a type for text? Text. So text is 0. And it looks like A is going to be whatever is here, text. So I'm just going to go ahead and add that. Text is equal to A. I guess we'll still hit an error on that in just a second because we haven't changed the decoder to use this new field name. All right, expecting an object with field name text. Let's find where that's coming from. Decode text tag. So this is now virtual DOM constants.text. And I'm just gonna split this onto a new line while we're here. All right. Great, so that first test passed and test.only was used. So let's move on to our next test. Let's just run all of these and see how many are failing now. None of them. All of those have passed. Okay. So that is making me feel like we're missing a lot of test coverage to do. What is this? Constant? Or this is not tested. There are probably tests for some of this in the remaining tests that we have to turn back on, but I'm just going to add these comments like this for the moment. Let's see. This is also going to hopefully have a test later. Encode. These encoders also are going to have problems. Okay, tagger. I'm pretty sure this will be covered by the events tests. Decode keyed node. Hopefully this has some tests somewhere. Encode to do not tested. Decode custom node. Decode custom node record. Okay. Markdown node, interesting. Decode the styles. I'm just kind of scanning through here looking for any string constants. These are the ones we fixed last time, and we still have this to do. Hopefully events is going to cover that. To do. This one's hopefully tested by events. Elm list decoder. Okay, if this isn't used, I don't really care about this, but presumably this will be used by some of these other decoders we just marked as to-dos. Great. Okay. Cool. So let's remove our debugging. And let's see if that is all the debugging or if there's more we missed. Nope. Okay. Where do we have a debug.log? That is fine for the moment. Here we go. All right. So we need to Elm format everything. Let's see, those are all in the tests folder. Ooh, okay. We didn't need to format all of that. Just test source. All right, and let's see what we have done here. So just like last time, just in elm-19, JSON internal representation is slightly changed, so we fixed that. We added this. We fixed some constants for a bunch of this stuff. I guess we can just go ahead and add all these to-dos, because we'll compare this against the master branch before we're done. Okay, here's the fixes we actually made, which makes decoding normal HTML nodes, and I guess I already added the ones for text nodes, work with the new internal structure for virtual DOM in elm-19. This file we'll come back to. Actually, descendant might pass. Let's check that real quick now. If we enable descendant test, does this pass? Yes, looks like it does. Okay, so we didn't actually have anything to do in descendant once we fixed these problems with the query tests. So this can, oh, that to do can stay. And these changes can stay, and the only can go away. We will reformat these. I'm not sure why VS Code is not, it looks like it's not formatting the test files, but it's formatting the source files. I'm not sure why that is. Okay, but this all looks fine. Queries, let's try to fix this. I think this will be an easy fix. It'll probably just be adding one more case to the decoder. So let's try bringing that back real quick. Lazy tests, npm test. No such type as 5. Okay, I'm going to guess that 5 is the thunk type. That's just the name that I know is used internally, and probably thunk. Then I'm not sure what L is going to be. L is probably going to be node. It's basically in our kernel code here. We have this force thunks function, which recurses through the tree and basically evaluates all the lazy code so that there aren't functions in the JSON object that we're trying to decode. That is just stuff I happen to know from fixing bugs previously in this library. Okay. Shoot, I lost my place. Okay, so the new one, no such type as 5. This is another one of these missing constants that we have. So thunk, I'm pretty sure it's this one. And if we run this now, it's probably going to say can't find fields, or expecting field thunk. Or actually expecting field node is our guess. Problem with the value here, expecting an object with field named node. Yeah, okay. So node is the string L. And where were we using node? Right here. And that fixes our to-do. This is virtual DOM kernel constants.node. Oh, interesting. Interesting. So this we saw was the value in this L field, which is the compiled name for the node field. And it looks like this is an array now. So I'm not entirely sure what these are supposed to be then? I guess this also, I think, means that probably this native code is incorrect, because this here is also looking for thunk and for type, which we know type here is supposed to be dollar. Okay, so this is to do all the field names and type constants are wrong in here. Okay, so this is actually going to be a little bit of work because we need to loop through and basically, I'm guessing that this null is the place that the evaluated, like we have a lazy HTML node. When it gets evaluated, it's actually the evaluated value is stored in the virtual DOM itself as well, so it's cached. I'm not sure what home is going to be though. So I'm going to try to look here in thunk. So the case of thunk, it has refs, which I'm guessing are the values that are used to determine when it's dirty or not. Thunk is going to be the function itself that can be called past unit. It'll get past the unit value and should return the generated HTML. And then node is going to be where it's cached. What's interesting here is that this is an array when we get it out here. So let's see if we can find where this field gets set in, whoops, in the source code. Yeah, okay. So when we render it, or when virtual DOM renders a virtual DOM value, if it's a thunk node, it's going to use the node value, but if this is false or undefined, we'll evaluate as false. Then we call thunk and set it to this. Then we pass that to render. So thunk, the value of what thunk returns should be a virtual DOM node. It should not be an array like this. So maybe this is a problem in the code here. If we just comment this all out, is this all undefined still instead of an array? If it is, then I kind of understand what's going on here. Nope. Okay. Let's make this fail for just a second. And I want to see the value that was in there, just at a slightly higher level. Okay, so this is the virtual DOM object. It's of type thunk. 5, I'm quite sure means thunk. L is an array. Yeah, I'm not understanding why this is an array. Because essentially we're calling, in the virtual DOM source code, it calls render with this value as the first parameter. vnode is required to have a dollar attribute. I guess if it was an array, this would just be undefined, and then tag. At this point, tag must be node or keyed node. In vnode, this would also be undefined. Yeah, I'm not understanding what is supposed to be going on here. Or I guess what I'm not understanding is how this value is coming out in our virtual DOM. Let's try console logging this again. Oh, thank you, VS Code, for the autocorrect. And where is this one test? I guess I should have found the single test that we care about. Let's do only this one. Okay. Oh, I guess this isn't printing out the entire value. How do we do that? We can like JSON.stringify this. Let me check the docs for that. And replacer, this can be null, and space is for readability. Okay. So let's do JSON.stringify x null 2. Okay. So here's the JSON value we're decoding. In here somewhere is this thunk thing. Let me grab this and stick it in a buffer. Okay. Maybe 5 is not thunk. Let's see. So this is E, it's a header. The funky themed is the class name. Let's find this in the sample HTML that we're creating. Okay, everything's funky themed. Header, ID heading. Header, ID heading. So we're here. And then children. The first child of this heading is the element we're looking at. So this is an A tag. Huh, okay. Oh no, my mistake. We're not in the sample HTML. We are in the sample lazy HTML, and the first child of the header here is a lazy node. Okay, so this definitely is a lazy or thunk node. It's got home. So home is this string that we're seeing. So I guess this is the value that's used to compute the lazy node that's passed to lazy. Okay. What's confusing me is I'm not seeing in the virtual DOM source code where that parameter that we pass to the thunk gets stored in the JavaScript representation of the virtual DOM itself. But I guess I'm gonna stop worrying about that and just follow what it looks like it's wanting me to do, which it looks like the first value in the array, the null, is gonna be the cached value if it's been evaluated, and then the second, actually here's one with multiple values. So is this like, what is this? This is the footer. Where does that come from? Okay, so that's lazy 2. Interesting. Okay, so it looks like the first value here is probably the cached value, and then any remaining values are the arguments that would be passed to the thunk. And this is not matching up with what I'm reading in the source code for Virtual DOM here, but let's go with what's happening in the actual code. And maybe it'll make more sense later as we go through. So I think we can comment this out for the moment. And this is also going to mean that all the code in here is also written for elm-html-test. So we're also going to have to update all this stuff. Okay. So we are now failing because of this field. That was just for debugging purposes. So let's put that back to L. This is now going to fail because it's getting an array where we thought we were expecting an object, which means we really want to decode the first value here. So I forget the name of that decoder. Is it the index decoder? Let's check. JSON index. Yeah, okay, so there's @ that we can use if all the keys are strings, but for getting an item out of an array, we want to use index. Okay, so we're going to take this. Okay, so in the field, in the L field, which is where we're at, we are, instead of this, we are going to do index 0 and then this. Okay, so I think this is the null. Now the next problem is this is going to be null instead of an object because this code that evaluates the thunks is needs to be fixed. And let's see, we need to import index. Okay, so here in that array, it's undefined, but we're expecting an object. So let's, assuming all of our decisions so far are correct, that means that the code here basically this branch. Okay, so I'm not sure what this first branch is. It's saying that if the v node is undefined and it's a tuple, interesting, I'm not sure when that would be the case. And let's bring this one back. So if the type of v node is not undefined, okay, great, and vnode.type, this we know is now called $, is thunk, which I think these virtual DOM constants we're also going to need. Let's, for the moment, just put a copy of this. Virtual DOM constants equals, and all we need right now is thunk. All right, and we'll start doing the same trick here. Virtual DOM constants dot node type thunk. And if it's node, so we also need node equals L. Virtual DOM constants dot node. Then, oh, interesting, but it's also sub-0 there, because this whole thing should be an array. Okay. Then here. So then, yikes. Okay, so then the vnode, all this stuff. So the vnode's cached node, and the item in position 0 in that array should equal this. I see. And then the args are coming from, oh geez, okay, this is kind of complicated. So we basically want args is going to equal this array minus the first thing. So that's dot slice, right, of 1. And then we apply the args, and vnode.thunk, interesting. It's like calling itself, passing itself as the first argument. I hope that's still correct. And then thunk is another field that we need the name of. Thunk is here. I feel like this is going to be different, because in this case it doesn't get past any arguments. Let's see if we can find where thunk is created. It's created here, so it's called from Elm code. What does the Elm code look like? This is not calling thunk directly. So where does this get called? Oh, I see. This is called from lazy. Oops, I keep hitting Command-Shift-F accidentally. Okay, so in lazy, thunk, oh, I see, gets past an array. The refs is the array. Okay. So that L that we were seeing is not node. That field we were seeing is the refs field. So this is the array of the function itself. Okay. Okay. So this actually is nicer for applying, because the function, which for some reason was previously passed, and then the arguments. Oh, I see. Sorry, thunk is just the context that the function gets evaluated in JavaScript. Okay, man. Okay, my brain is kind of unwrapping a lot of stuff here. So refs is what we're seeing. This is refs, and this is refs. We don't actually know what node is yet, because it's been undefined. We haven't seen it in the JSON. Okay. So in this case, if things are undefined, the node type is, let's split this out a little bit, and that, and that. Okay. So if the node is an object, if its type is type thunk, and it doesn't have the node cached already, we're not sure what this is going to be. Let's just stick node in, because I think we're not actually going to use the real value from virtual DOM, because we never called the real virtual DOM to evaluate things. We're just going to evaluate ourselves here. So if the node is not cached, then we are going to store into this cache the thunk, which we get from the vnode. So we're gonna need to have thunk equals this. I'm not sure what this is gonna be yet, so we'll need to find that constant. So vnode virtual DOM constants dot thunk, and we will apply, I think we just apply the arguments now, because this already contains function in itself. So I think that's going to be correct. But this is kind of a big leap of faith here. All right, then in internal types, we don't know what node is yet. Or we don't know the real value of the node field name, but we're kind of generating it ourselves, so this should be fine, I think. All right, then this code is not correct. This is, I'm typing Elm code in JSON, so this should all be colons. Okay, so we didn't get this far because we need to recurse into other kinds of nodes. Specifically this one. If the vnode is an object and it has kids, we learned it's called now instead of children, .kids, and we learned the name for this, it's the letter E. I'll put this one up here, kids. Then we replace the kids by recursively calling into kids again, and we call force thunk on all the kids and replace them. So I think that's the reason we didn't get the cached thunk value in here. All right, we got into this latest code, so it has found a node which is of type thunk, and it's trying to evaluate the thunk, or the lazy HTML node. I guess we should console log the vnode here. So I'm not entirely sure what's going on. I was just writing all this code kind of blind moments ago. So let's see. Right. We didn't figure out what these values are. So it looks like the thunk field is the letter M. It also looks like the K field is the node field. And L is the refs, like we saw. Because home is the string value. Okay, let's see if that gets us further. This did not work because I'm passing the wrong thing. Args does not in fact exist. What we want to be passing is the refs from the vnode. Actually, let me just pull that out as an argument, or as a local variable. All right. So we got to something different. We got into children, 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 and then k, and k is node. And we got an object that looks like a node now. Oh yeah, and I think the problem now is we put this extra code to dig into this array, but it was wrong. I was just confused about what the array was supposed to be. So I think we can put that back, and this should get us on. Because this value is the evaluated value that we produced here. And it looks like what the virtual DOM node is supposed to look like. It's an A tag, it's got an href, it's got some text in it. So let's see if that does it. Yeah, great. Okay, that passed. It looks like these other types. Okay, so this is to do tested, hopefully tested by events, and this one is to do not tested. I'm not even sure what this case is. Is there test coverage for this? I'm not sure. This is basically saying that the virtual DOM node itself is a tuple instead of a node. I don't understand what that would be for, but hopefully there's test coverage. If not, we'll come and deal with this to do later. Let's see, so we want to get rid of the debugging, get rid of this debugging. I guess we can join this stuff back up. And it said we had a test.only. Is that true? Yes. All right, so that must be in here only. Here we go. I guess I'm being optimistic that this passes all the lazy tests. Oh great, and it looks like it does. So then we need to Elm format again. npm test. And I think this will probably wrap it up for me tonight. We just need to work through and finish committing this. And yeah, if anyone has questions or anything else they want to chat about tonight, speak up in the chat while I am getting this committed, and we can chat for a bit. But otherwise, we will be wrapping this up as soon as we get this committed and pushed up. So let's see. Let me add a note that this is duplicating stuff in internal types.elm. Internal types.elm. Okay, great. Then we've got some to-dos of other stuff that we didn't see the test coverage for yet. Then, oh, we didn't actually need this change. We can put that back. Then this is good. This one we fixed. And this we're going to put back and see what tests, how many tests are failing now. Oh, great. Okay, so we are down to 25 test failures. which is pretty good compared to where we were at starting today with 104 or something. Let me just run Elm format again before we finish this up. Let's make sure it's run on source as well. Normally I'd just run it on the whole project folder, but in this case there's a bunch of non-get ignored folders that have a bunch of Elm packages kind of copied in. And this, I think, is because my VS Code keeps trying to compile things for elm-18, so we will just throw that file away. All right. So our previous message, down to 104. Okay, now we are down to 25. Is that what it was? My short-term memory is not good with numbers. Yeah, cool. Down to 25 test failures. And in this case, we fixed virtual DOM node decoding for normal nodes, text nodes, and lazy nodes. Great. And we will push this up. I forget which password I have on here. Great. And we are done with this file. Cool. Well, thanks everybody for tuning in. I'm just doing this one segment stream tonight, but I am planning to come back to work on this some more on Saturday morning Pacific time, maybe mid to late morning again, like I usually do. So I have to see all of you back then. And what else? Oh yeah, so this current project of upgrading elm-html-test for Elm-19 is definitely an extremely kind of technical and deep nitty-gritty kind of project. I don't know, there was a lot I was keeping in my head today. Once we get this done, I'm gonna go back to trying to do more kind of faster paced kind of introductory or tutorial projects, or look at smaller packages. I'm going to do definitely open source maintenance of stuff. We'll probably do some Haskell programming of getting Elm format ready for the 1.0 release. But in general, hopefully I will have some, I'm planning to have some projects that are more accessible to people, especially people who are just starting out with Elm, or people who are more focused on web development, rather than this kind of deep technical stuff into the internals of Elm testing. But this has kind of been a high priority at the moment to start getting Elm as a platform ready for people to use in Elm-19. So thanks for tuning in. Let me know on Twitter if there's stuff you'd like to see in future streams. And yeah, thanks. I will look forward to chatting with you all later. See ya.